And so we introduced Dr. Sergio Quesada from ENCO. ENCO is a company who supports also writing and managing projects. We work with them also in the Recover project, and we work with them in BIOnTOP project. And so Dr. Quesada has a PhD in chemistry, more than 10 years experience in research and development. He's also published scientific paper and patents. He was a CEU European project manager in ENCO, and he takes care of market analysis, innovation, exploitation, and supports a partner to get and manage also their budget, so millions of euros, so that we can go to from financing. And it's very interesting for this new call that will be in September, new calls which will come. We are working in the BI project, but also in our Horizon project. So we experience we anchor in several different types of calls and projects. And he will introduce BioNTOP project today. But as I said, we are also in our that will be presented in these 2 days.
Thank you a lot. Well, hello everybody. First of all, I would like to thank you a lot to the organizing committee of ECOFUNCO for the opportunity of present our project BIOnTOP, in which we participate at ENCO, as you have said. Thank you a lot, Beatrice and Patricia, for the presentation of the project. So let's directly go to the details. The motivations of BIOnTOP are surely very similar to many of the projects presented here. It is the problem of the plastic age in which we live currently, and its very concerning and harmful impact in the environment. Despite all the efforts, the end of life of 68% of plastics we use daily is still insufficient. And this is a problem also for textiles used nowadays. Among the causes, as you can see in the slide, there are the multi-layer structures of packaging. The point of action of BIOnTOP is focusing mainly on PLA, which is the biodegradable bioplastic most used nowadays. But PLA is currently only biodegradable under thermophilic conditions in industrial composting or digestion plants at limited thickness. Several companies, such as Novamont and BASF, has developed polymers that can meet home compostability requirements, but nevertheless, further improvements are needed to provide cost-effective solutions with high bio-based contents and suitable performance for demanding packaging applications, while still achieving compostability in mild conditions. Here you can see the main characteristics of BIOnTOP project and its consortium. The project is a research and innovation action which is actually in execution. It belongs to the BBI initiative, as you have said, and it finishes in May next year. In the consortium, we are 21 partners among 8 different countries. We cover from small Eastern European firms to world-leading American headquartered global company, represented here by its Netherlands technical office, who bring unique knowledge to the project like Total Corpion. And here you can see a representation very schematic of BIOnTOP. Our main goal is to deliver novel bio-based and biodegradable packages based on versatile copolymers and coatings that not only optimally preserve the packaged products, of course, but also our resources. They are based on more than 85% renewable resources, partially produced from byproduct biomass, and they are also recyclable. Our packages are compatible with a broad range of applications, but also multiple end-of-life options like materials and organic recycling, home and industrial composting, and so on. And this is due to the tailored PLA formulations and removable barrier or monomaterial coatings that we are developing. The different conversion processes, as well as the post-users, waste sorting and recycling, will be upscaled following our approaches, our optimized approaches. And also, besides enable recyclability, our coatings also bring innovative functionalities to the consumer, like non-stick, product release, easy emptying packaging, or waterproofed fabrics. All of them comply with the industry needs because they are cost competitive, they are compliant with all European package regulation, for example, for safe food contact. And this is because the intention of BIOnTOP is also to have a great impact on European bioplastics markets and end-user sectors. And they are also compliant with rich regulatory thanks to the tasks from ARCA labs. So let's go briefly into each step of the project. Regarding the formulation of the materials, we have formulated 2 PLA-based copolymers using organic acids obtained from natural and waste resources, with specific formulations for each end product using additives extracted from biomass, like waxes, oligomers, natural derivatives, plasticizers, organic fillers, etc. And also reactive blends based on previous formulations. These formulations have allowed us to tune crystallinity, thermomechanical properties, and biodegradability while preserving a very good processability by blown film and cast sheet production. These formulations will allow us to deliver recyclable-by-design solutions, which is one of the central points of BIOnTOP. Very briefly, regarding synthesis, as you can see in the slide, we have used direct polycondensation and batch synthesis, followed by reactive extrusion or batch copolymerization derived techniques. And for the fabrication, for the manufacture, extrusion, lamination, thermoforming, melt spinning for nets and textiles and for non-wovens, blown extrusion or of recycled and virgin copolymers, depending on the final product. And using this methodology, we have prepared the following demonstrators that you can see in the slide. Our final products are mechanically recyclable, industrially and home compostable, and they will be even suitable for anaerobic digestion, but also recyclable for multiple use of secondary packaging. Regarding coatings, we will enter more in detail in the next slides, but just to say that we have developed removable barriers or monomaterial coatings. Moreover, the barrier properties have been enhanced to decrease permeability and to compete with fossil packaging. In the field of textile packaging, new PLA coatings allow reprocessing without significant loss of properties. And they also bring other properties as well as innovative functionalities to the consumer, like non-stick, product release, AC emptying, and so on. And to finish, we focus on the end of life of our demonstrators. A central concept of BIOnTOP is recyclability by design. This means that we have developed formulations and products that allow us to tailor, to adjust the end of life to the final application. First of all, we are developing a system able to monitor and classify the novel materials from other standard plastic wastes. Infrared spectroscopy or hyperspectral imaging are combined with chemometric tools to characterize the selected developed copolymers and to develop classification models that are able to discriminate the BIOnTOP materials among other wastes. Currently, we are working on the evaluation of the recyclability, the biodegradation, and the environmental impact of the demonstrators. First, material sorting using spectroscopy and imaging. Second, multi-layer recycling using barrier washing, layer separation, and so on. Third, material reprocessing after decoating using, for example, cleaning, milling, reprocessing via extrusion to pellets, and so on. Fourth, biodegradation and home composting anaerobic conditions according to ISO standards in mild conditions. And fifth, organic recycling in the same conditions. Furthermore, we are developing a predictive biodegradation modeling tool as support for eco-design of the new materials applications. We are gathering data from all the partners in terms of biodegradation profiles, both in industrial and home composting conditions, and developing models to discover some of the key parameters influencing the biodegradation and disintegration, such as composition or macroscopic structural aspects. Over these data, we will employ machine learning algorithms to set key values, such as degradation or disintegration time and percentage. These models are being now used to optimize formulations for each demonstrator and to develop a CBR, a case-based reasoning model. It is an experience-based approach based on artificial intelligence to solve new problems of end of life by adapting our developed results in BIOnTOP to solve future problems in biodegradability of polymers in future projects by showing the keys to improve end of life on the basis of environmental parameters, composition, and materials processing. The final objective is to have a tool to perfectly tailor the formulation and the proceeding and the synthesis procedures and manufacture to an optimum end of life for each application. And to finish, I would like to enter a bit in detail, of course, in coatings that we are developing in BIOnTOP. As you know, high permeability limits the application of bioplastics for packaging sensitive food products. In order to avoid this limitation, the barrier properties of the bioplastics developed have been enhanced using previously developed protein-based coatings in projects like layers and thermo-wet that you can see there in the slide. For example, we are using novel fatty acid grafting to manufacture nanometric layers, which, in spite of being applied to multi-layer films, can be later removed and do not jeopardize, do not affect their later recyclability or their biodegradability. The hydrophobic grafting contributes to reducing product waste at end of packaging use through a release easy emptying effect. Likewise, in the field of textile, most used coatings, like, for example, polyamide, polyurethane, are not bio-based and of different nature than the fibers that they are applied on, limiting the properties of the recycled materials. And here, PLA, or BIOnTOP copolymers, based on PLA-based coatings and fatty acid grafting have been developed, allowing reprocessing of the coated fibers without significant loss of properties. So in conclusion, our coatings are multifunctional, used for barrier, easy emptying, and sensory purposes. In terms of barrier properties, our coating provides barrier to oxygen and WEEE, and ultraviolet, also barrier to aroma, thanks to polysaccharides like alginates, barrier to water vapor, to grease, and to liquids. For example, fatty acids for repellents, or plastic, or PLA coatings for textiles. These multifunctional coatings have a bio-based content above 95%, and are enhancing PLA's oxygen and humidity barrier by a factor greater than 10. So they are suitable for sensitive food and personal care applications also, and coated PLA textiles with better barriers, thickness, and hydrophobicity with water contact angle superior to 120 degrees. In first place, we are developing, processing, and testing a new water barrier and repellence coating. In order to obtain enough water barrier and repellents, we are using bio-based fatty acid through solvent-free grafting. A fatty acid-based humidity barrier nanoscale coating for films, resulting from solvent-free chemical grafting, is also being developed to enable deposition of monomolecular layers that drastically improve the barrier properties. We are applying the grafting on wheat protein-based barrier coatings, as well as on PLA films and textiles to reach the optimum value of oxygen barriers. The fatty acid grafting, as well as polysaccharides, will also be tested on PLA textiles as aroma barrier. In second place, we are processing the barrier and repellence coatings for films and trays for improved performance and scalability. The left diagrams here show thinner films and an alginate and whey protein coating for lead film application. And in the right diagram, you can see the oxygen transmission rate of the whey protein coated films for our trace demonstrators. As you can see, we have reached great improvements in barrier properties, but I also would like to highlight that we are using process modeling and simulation in steps like the protein denaturation and the drying stages as a supporting tool to improve performance, up scalability, and also to study the effect of the different steps in the coating development. And to finish, we are producing and characterizing PLA and fatty acid coatings for textiles. Here in the slides, you can see alginate coatings for textiles, for tea bags. Currently, we are following the different procedures, experimental procedures that you can see in the slide. We are currently updating and improving the glass transition temperature by screening of dispersing agents, and we are also improving the blocking coatings required and carrying out stain resistance and repellency tests. And finally, I would like to mention the task that we are developing at ENCO in the consortium. Among other tasks, we are the leaders of Work Package 7, which is devoted to market strategy and innovation impacts. At ENCO, we are laying down the basis for the establishment of BIOnTOP value chains for circular bio-based packaging, and we are setting up suitable business models to catch new market opportunities, also considering the consumer perception. At ENCO, we are maximizing the innovation impacts of the projects for contributing to the uptake of BIOnTOP for economy and jobs growth by properly managing and protecting the BIOnTOP knowledge and results, and establishing a robust and a solid plan for communication, dissemination, and exploitation of our results in the market and in the industry. Here at ENCO, we are also connected in a strategic dialogue among general public and policy makers to lobby for the setup of new end-of-life standards and materials at the European level, as well as developing policy recommendations to incentivize the use of biopackaging. And this is so because here at ENCO we have more than 30 years experience in European funding lines, with a history of 15 completed projects and 14 ongoing projects. In fact, we will be very active in this CBE call. So from here, I would like to make a call to all of you, to the partners interested in this call, to start a dialogue with us about the consortia that we are currently forming in order to partner together and to maximize our joint possibilities for new projects and for improving the end of life and all the current problem that we have with plastics and with packaging usage. That's all from my side. Thank you a lot for your attention.